process of joining either similar or dissimilar materials with or without application of pressure and or filler material, but with application of heat. Heat is mandatory. Application of pressure or filler material is dependent on the process, right? So finally, you will get a homogeneous joint out of it. So we have discussed about classification of welding. There are two main types. One is pressure welding, second is fusion welding. So what is pressure welding? What is fusion welding? We have discussed in detail. So the first process of welding, that is electric arc welding, was completed yesterday, the principle of working. Okay, then gas welding we have seen. So mainly used, that is oxyacetylene gas welding process, the procedure we had discussed. Okay, then finally soldering, brazing and welding. These three processes were almost complete. So two other processes we have to study in welding. One is the tungsten inert gas welding, also called as TIG welding. So this tungsten inert gas welding, okay, it is also known as gas tungsten arc welding, that is GTAW. This is a arc welding itself. It is not related to the total gas welding. It is an arc welding method that uses a non-consumable. Sometimes, depending on the need, consumable electrodes may also be used to join two or more parts. Okay, you take down this rough sketch. So the first sketch you can refer. I will give you 2 minutes time. You can take down. You can take down the sketch. Okay. So this is called as tungsten inert gas welding. It comes under arc welding only. Why? Because here, see, when do we call a welding process as gas welding? Whenever you use any particular mixture of gas for producing the flame. Here, we are not using the gas, whatever that is inert gas is there. This is not used as a flame. It will be used as a flux material. Okay, so it will prevent whatever oxidation process that we discussed yesterday. So the inert gas will form a layer, okay, in the surrounding, and it will prevent the oxidation process. In this video, you can clearly see the arc welding process wherein there is a flame and an filler material is kept here. So filler material will be burning and it will be forming droplets or modules. Okay, it will form a pool. As you move further, because of capillary action, you can see here the gap is filled, right? So that the welding process is completed. So continuously this filler material will be forming a bubble like this and it will be joining the flame. Okay, so this is called as tungsten inert gas welding or TIG welding. So what are the important parts? See, one, the first one is the inert gas cylinder with a regulating arrangement to control the flow of gas. Okay, there will be a torch, okay, or welding gun, okay, wherein flame will be produced. Okay, there will be a filler material. Okay, and the workpiece is connected to one terminal, and the whatever welding torch is there, that is connected to the second terminal of the direct current. So when you bring it nearer to the workpiece with some small air gap, there will be a flame formed so that the filler material is kept there. It will burn and it will form a module or a droplet. Okay, so what is the function of this inert gas? We are supplying inert gas also here. This inert gas will form a layer around this welding area so that there is no direct contact of oxygen to this area, so that the welding process can be completed without contact to the atmosphere. So this is the process of TIG welding, right? So what are the important components used in TIG welding? The following one is power supply, either AC or DC. Okay, there will be a non-consumable tungsten electrode. Okay, sometimes consumable also. In the video, we saw a consumable one depending on the application. Next is the inert gas supply, which acts as a uh, layer and prevents the oxidation. So here directly we are not using any flux. The inert gas itself acts as flux. Okay, there will be a filler rod depending on nature of workpiece, right? And welding head will be there. That is the welding gun. These are the different components of TIG welding mechanism. In this sketch, we could see clearly the different components, right? Please make a note.
Yes.
Okay. So the same working, whatever we discussed, it is described here. So the workpiece to be welded is placed on. As the electrode is brought near the workpiece with a small air gap, okay, an arc is produced. That is why we call it as arc welding here. Okay, the gas, whatever we use, it will be just a flux material. Okay, so this arc is used for melting and welding the workpiece. Sometimes whenever we use the filler material as a additional, so that filler material will form droplets, it will form a pool. Okay, when we don't use, a pressure will be applied so that the parent material itself will melt and it will attach with the second component. Okay, so high melting points of around 3500 degrees centigrade can be expected here. Okay, So the usage of filler rod depends on the nature of workpiece. Okay, if the parent material itself melts and it will form a loop, then filler will not be used. Okay, if filler rod is used, it is continuously melted by the arc and it will be fed into the weld pool. Pool is nothing but a group of droplets of the filler material, as we saw in the video. So inert gas will be continuously supplied. It acts as a flux. The inert gas forms a gas shielding around the weld so that external atmosphere contact will be avoided, so that the weld joint will be very strong. There will be no question of oxidation, right? So this is the working process, right? So what are the advantages and disadvantages of this TIG welding? TIG welding process gives very high quality welds. Okay, the weld is automatically protected by the inert gas, no question of any oxidation that can occur, so that the weld whatever we produce will be very strong. No slag is provided. Slag is waste material that will be collected around the weld, which need to be cleaned in general arc welding, but here no such slag. If you ask why, at any point of time the filler material forms a pool. Okay, that pool by cavitation automatically goes and fills the weld. There will be no spilling of any filler material particles. Slag is nothing but the spilling of the filler material particles around the weld joint. So such issues will not be there. TIG welding can be done in any position easily. Okay. Limitations are it is a very slow process, right? Highly skilled labor are required. Okay. Welder is exposed to huge intensities of light. Strong protecting equipments are needed, and it is expensive compared to MIG welding process. These are the advantages and limitations. Please make a note of it. Sometimes they may ask you to write the advantages and limitations alone. Now, what are the applications for which materials can we use? A wide range of materials can be welded by this mechanism, like stainless steel, alloy steel, aluminium, titanium, copper, magnesium, nickel alloys, etc. Wide range of materials can be welded. So this is the application.